Today's the presentation for our project. That means the development of commercial warehouse. As many speakers explained us during this semester, we do not always choose our team, but we must be able to work with everyone. We formed our team when we didn't even know each other. But we present each other, and then we know right now the strength and the weakness of each of us, and this will really help us carry out this project. We have mainly theoretical knowledge and very little practical knowledge. However, thanks to the advice and questions from our two PEs, Pierre Quaron and Xavier Miranda, we have successfully completed this warehouse construction project. And we're going to present today 4 phases of our project: the erosion control, the hydrology, the structural design, and the foundation design. The erosion control, we took some data from the Georgia Soil and Water Conservation Commission, just to be able to really work on the land. And reading about the regulation for Forsyth County, where the project is located, we learned that we're going to need to have 3 phases on the erosion control. The first phase is just cleaning area, cutting down unnecessary trees, and removing some rocks. The second phase is just grading and putting the infrastructure like storm and sewage, just to be able to drain some water. And to finish, the phase 3 was the main one, where we have to build the infrastructure. This is why we also using AutoCAD Civil 3D, just trade and build the SD3 pound with the emergency spillway on it, just in case one of the pipe just gonna blow up. And just to be able just to do everything and then make some calculation to know the drainage we're gonna use. This is what we're gonna also explain a little bit how we have the pipe with the hydrology part.
Okay, for hydrology, we obtain rainfall data 14 from NOAA Atlas. And in hydrology, we focus on draining stormwater by designing sanitary sewer and pipe network. To create the pipe network, we use AutoCAD and Civil 3D. To create proper boundaries and polyline. Also, while creating the pipe network, the type of inlet and type of catch basins are chosen for design. And a gutter spread is designed following Forsyth County Unified Development Code. In this design, there is a stormwater discharge point that discharges into a creek on the property. A detention pond is not necessary. 4 feet of cover and a minimum of 2 feet separation between stormwater and sanitary sewer is required per Forsyth County regulations. To design the stormwater pipes, a 50-year storm is exported into hollow structural sections known as HSS. Using Excel, we calculate the area and runoff coefficient for each inlet, which After that, it was imported into HSS to calculate pipe size. Finally, the pipe network is designed for a 50-yard storm and a 100-yard hydraulic grade line. The maximum velocity is 15 feet per second. The minimum time of concentration used to design is 5 minutes. All pipes are designed according to HSS. The minimum pipe size, spacing, and maximum length of pipe are determined using Article 21 of Forsyth County Unified Development Code.
For the drawings, we used AutoCAD, and the drawings are from a professional architect, and we designed the structural components to the building. The drawings consist of a roof plan, floor plan, foundation plan, and also a detailed view of each of the components from each of the certain pages. And we also have an elevation view. This was given by the architect to show the general design of the building, and it gives the front elevation, rear elevations, and the sides.
So our Excel file was used to formulate a formula for our live loads and dead loads on the warehouse. From the column spacing on the east-west direction and the north-south, we were able to get a dead load at each floor and roof respectively. Using the LRFD equations for each beam and column, we were able to use the live loading formula found in the ESCE for building codes to formulate a maximum LF-RD combination. And for each member, because we just supporting one floor for the warehouse, so we did that for just the roof and for the floor.
For the wind load calculations, we used Microsoft Excel to find the KZT, the C and G value from the IBC building code. For each wind direction considered an exposure category that adequately reflects the characteristics of ground surface regulations shall be determined for the site at which the building or structure is to be constructed. Account shall be taken of variation in ground surface roughness that arise from natural topography and vegetation as well as from constructed features. For each selected wind direction at which the wind loads are to be evaluated, the exposure of the building or structure shall be determined for the two upwind sector extending 45 degrees, either side of the selected wind direction. The exposure in these two sectors shall be determined in accordance with this, exposure resulting in the highest wind load shall be used, representing winds from that direction.
So these are the dimension for foundation design. Pretty much after the excavation, the surface was leveled, and we used a formula to estimate our square footing and to find also the bearing pressure. And from that, we were able to estimate the slab on grade reinforcement, and the Excel file just gives us the values to use on our warehouse setting. Oh, and this just gives a geotechnical evaluation before or to start the foundation analysis. The area of the square footing was 25 feet square with a basis of 5 feet. The allowable bearing stress was 100 per square foot. And finally, the area provided for the rebar was about 4 inches per 2 feet width. And these are the specifications we used in operating our foundation. And this shows our foundation plan. Schematically, the plan shows how it was supposed to look like, and then it describes how the column bars are all with links and the levels of foundation before the concrete works.